Welcome to the Deep Dive. Today we're going to be exploring the world of machine learning.
Oh, yeah.
And
it's going to be fun.
yeah, it's a really interesting field, and we've got a whole stack of articles and research papers here that we're going to be diving into.
Right.
So.
And the thing about machine learning is it's not just one thing.
Right.
You know what I mean? It's more like a bunch of
like different approaches?
Yeah, a bunch of different approaches, like different tribes almost.
Tribes.
Yeah.
Okay, so you're saying there's not just one way that machines can learn.
Exactly. There are 5 major schools of thought, like 5 different tribes, and each one has its own kind of like master algorithm
Wow.
that they use to try to crack the code of learning.
Okay, I am hooked. Tell me more about these tribes and their master algorithms.
All right, well, before we jump into the tribes, I think it's important to understand, like, what is the fundamental problem that machine learning is even trying to solve?
Okay, yeah, what's the challenge that unites all these different approaches?
It all boils down to this idea of generalization.
Generalization.
Yeah, like how can a machine go beyond just memorizing the data that it's given and actually learn to make accurate predictions about stuff it's never seen before?
Okay, I see. So it's like, how can a machine learn from experience and apply that knowledge to new situations, just like we humans do?
Yeah, exactly, but it's a lot harder than it sounds. Imagine you've got a database with like 1 trillion records.
1 trillion?
Yeah, 1 trillion records, and each record has 1,000 fields.
Oh, wow.
And each field is just like a simple yes or no answer.
Okay.
Even with all that data, you've barely scratched the surface of all the possible combinations and scenarios that could exist.
Right, because there's just so many possibilities.
Yeah, it's like trying to understand the entire universe by just looking at a single grain of sand.
Wow. Okay, so the stakes are high.
Definitely.
All right, so let's meet these tribes.
Okay.
First up, we've got the symbolists. What makes them unique?
Well, the symbolists, they take their inspiration from philosophy and psychology and logic. They see learning as kind of like the inverse of deduction.
The inverse of deduction.
Yeah, they're trying to figure out general rules from specific data.
So instead of starting with a rule and applying it to a specific case, they're working backwards from specific examples to uncover those hidden general rules.
Exactly, like detectives searching for clues.
I like that.
They use techniques like decision trees and rule induction to try to build this logical framework for understanding the world.
So they're looking for those universal truths within the data.
Yeah, and one of the cool things about symbolist models is that they're transparent. You can actually follow the logic and see how they arrived at a particular decision.
That's really important, especially when we're talking about AI making decisions that could affect our lives.
Mm.
You know, we want to be able to understand how those decisions are being made.
Absolutely. Transparency is key. But of course, every approach has its limitations. What do you think might be a challenge for the symbolists?
Well, if they're all about logic and rules, I imagine they might struggle when faced with data that's messy or ambiguous. You know, the real world is rarely black and white.
You're exactly right. They can get tripped up by noisy data or complex concepts that don't fit neatly into those rule-based systems.
Right, like trying to teach a symbolist machine to recognize a cat in an image. There are so many variations in shape and color and pose. It would be almost impossible to come up with a set of rules that covers every possibility.
Exactly. It's like trying to define beauty with a mathematical formula. There are always exceptions.
So the symbolists are the logical thinkers searching for universal truths, but they can get bogged down by the inherent complexity of the world.
That's a good way to put it. So who do you want to meet next?
Okay, we've met the logical symbolists. Now let's move on to the connectionists. They sound fascinating.
Ah, yes, the connectionists. These guys take their inspiration from the human brain.
So we're talking about artificial neural networks, trying to mimic the way our brains learn.
Precisely. They see learning as this process of interconnected neurons that are constantly adapting and adjusting their connections based on experience.
And their master algorithms backpropagation, right?
You got it. Backpropagation is what allows them to train these neural networks to recognize patterns and make predictions.
And neural networks are everywhere these days. They're used in everything from image recognition to language translation. What makes them so effective?
They're incredibly good at handling complex data, especially unstructured data like images and audio and text. They're like masters of pattern recognition.
They can see patterns that we humans might miss entirely. That's what makes them so powerful for tasks like facial recognition or predicting customer behavior.
But there's a catch.
Though there's always a catch. What is it?
One of the big challenges with connectionists is what's called the black box problem.
The black box problem.
Yeah, neural networks can be so complex with millions or even billions of parameters that it's really hard to understand exactly how they arrive at a decision.
So it's like we've created these powerful learning machines, but we don't fully understand how they think.
It's kind of unsettling, right?
Yeah, a little bit. It's like we've unleashed this powerful force, but we don't have complete control over it.
And that raises all sorts of ethical questions about bias and fairness and accountability.
It's like with great power comes great responsibility, and we're still figuring out how to use this technology responsibly.
Exactly. It's a work in progress.
Okay, so we've met the logical symbolists and the brain-inspired connectionists. Who's next on our list?
Next up, we have the evolutionaries.
Evolutionaries. That sounds intriguing. Tell me more.
Well, as you might guess, they take their cues from the process of evolution itself.
Oh, wow. So survival of the fittest, natural selection, that kind of thing.
You got it. They use genetic algorithms and genetic programming to simulate evolution on a computer.
So instead of programming a machine directly, they're setting up this kind of digital ecosystem where solutions compete and evolve over time.
Exactly. It's a process of trial and error mutation and selection where the fittest solutions survive and reproduce, passing on their traits to future generations.
That's fascinating. It's like they're harnessing the power of nature's own learning algorithm.
Pretty much. What kind of problems do you think they would be good at solving?
Well, if they're all about evolution and adaptation, I imagine they'd excel at problems that have a lot of possible solutions, problems where you need to explore a vast search space.
You're on the right track. They're great at optimization problems, finding the best possible solution out of a huge number of possibilities.
So they're like the explorers of the machine learning world, constantly searching for those hidden gems of solutions.
I like that analogy, but of course they have their challenges too. What do you think might be a drawback of this approach?
Well, evolution is a slow process. It takes many generations to see significant changes. So I imagine these evolutionary algorithms could be pretty time-consuming and computationally expensive.
You nailed it. They can take a long time to converge on a solution, especially for complex problems.
And sometimes the best solution isn't immediately obvious. It might take a lot of iterations and refinements to get there.
Exactly. Patience is key with the evolutionaries. All right, ready to meet another tribe?
Absolutely. We've met the logical symbolists, the brain-inspired connectionists, and the evolutionary explorers. Who's next in line?
Now we enter the realm of the Bayesians.
The Bayesians. What sets them apart?
The Bayesians are all about probability and uncertainty. They approach learning as a form of probabilistic inference, where you constantly update your beliefs based on new evidence.
So they're like the statisticians of the machine learning world.
Exactly. They're very data-driven, and they use Bayes' theorem to update their beliefs as new data comes in. It's a continuous process of refinement.
So it's like they're playing a never-ending game of Clue, constantly gathering clues and adjusting their hypotheses.
That's a great way to think about it. They're always weighing the evidence and making the most rational decisions based on the data they have.
What types of problems are Bayesians particularly good at?
They excel at handling uncertainty, incorporating prior knowledge, and making robust predictions even with noisy or incomplete data.
So they're the cautious, data-driven thinkers of machine learning.
Precisely. But they also have their limitations.
I was just about to ask that.
Yeah.
Every approach has its trade-offs. What are the challenges that Bayesians face?
One challenge is that Bayesian inference can be computationally expensive, especially when you're dealing with complex models and large data sets.
It takes a lot of processing power to crunch all those numbers.
Exactly. And another challenge is that the choice of prior probabilities, those initial beliefs that you start with, can influence the outcome of the analysis.
So if you start with biased assumptions, you're going to end up with biased results.
That's the risk. It's important to choose those prior probabilities carefully and to be aware of their potential impact on the analysis.
It seems like there's a delicate balance between using prior knowledge to inform your analysis and letting the data speak for itself.
Exactly. It's a constant dance between the two. So we've met 4 tribes so far: the logical symbolists, the brain-inspired connectionists, the evolutionary explorers, and the probabilistic Bayesians. Who's our final stop on this tour?
Okay, let's meet the last tribe, the analogizers. What's their approach to learning?
The analogizers are all about finding similarities and making comparisons. They learn by looking at how closely things resemble each other.
So they're the pattern matchers of the machine learning world.
Exactly. They rely on this principle of similarity, the idea that things that are alike are likely to behave in similar ways.
It's a very human way of learning.
Yeah.
We often make judgments and predictions based on how closely something resembles something we've seen before.
Right. It's like judging a book by its cover or a person by their clothes. We make snap judgments based on superficial similarities.
So what kind of problems are analogizers good at solving?
They're great at handling complex data distributions, and they work surprisingly well in low dimensions.
No dimension.
Yeah, when you have a small number of features or attributes to consider, they're also relatively simple to implement and understand, which makes them popular for things like recommendation systems.
So they're the pragmatists of the machine learning world, relying on straightforward comparisons to make sense of the data.
That's a good way to put it. But they also have their Achilles heel.
Of course they do. What is it?
It's something called the curse of dimensionality.
The curse of dimensionality. That sounds ominous.
It is. As the number of features or attributes in your data increases, it becomes harder and harder to find meaningful neighbors. In high-dimensional spaces, everything starts to look equidistant from everything else.
So it's like they're great at comparing apples to oranges, but they struggle when you throw in 100 other fruits.
Precisely. Too much information can overwhelm them.
So we've met all 5 tribes now. The logical symbolists, the brain-inspired connectionists, the evolutionary explorers, the probabilistic Bayesians, and the pragmatic analogizers. What an incredible diversity of thought.
It's amazing, right? And they're all contributing to this grand quest to understand the nature of learning and intelligence.
It's like they're all climbing the same mountain, but taking different paths to reach the summit. And that brings us to a fascinating question. Is there a single path, a universal approach, that can unify all these different tribes?
The quest for the master algorithm. Perhaps that's a story for another time.
I can't wait to hear it. This has been an incredible journey so far, exploring the 5 tribes of machine learning, and now we're on the hunt for the elusive master algorithm.
It's going to be an exciting ride. Buckle up.
I'm ready.
Welcome back to the deep dive. Before the break, we were talking about all those different tribes of machine learning.
Yeah, it's fascinating how each one has its own unique way of approaching the challenge of learning.
Right, like different tools in a toolbox.
Exactly. But could we maybe combine those tools? Like create some kind of hybrid learning machine that draws on the strengths of each tribe?
That's the big question, isn't it? Can we unify these different approaches into some kind of master algorithm, a single learning machine that can adapt to any problem, any data set?
It would be incredible, right? Like assembling a team of superheroes, each with their own special powers.
I like that analogy. So we'd take the logical reasoning of the symbolists, the pattern recognition of the connectionists.
The evolutionary adaptability of the evolutionaries.
Right. And the probabilistic rigor of the Bayesians.
And don't forget the pragmatic simplicity of the analogizers.
Of course. We need all of them. Imagine a learning machine that could seamlessly shift between these different modes of thinking.
Choosing the best approach for each situation. That would be amazing.
It would be revolutionary. It could reason logically about symbolic data extract patterns from complex data sets, evolve novel solutions, weigh the evidence, and make probabilistic judgments.
And find intuitive solutions based on similarity.
It would be like the ultimate learning machine.
But is this even possible? Or is it just a pipe dream?
Well, it's definitely a huge challenge, but there are researchers working on it trying to bridge the gaps between these different tribes.
Are there any promising areas of research? Anything that's getting close to this idea of a master algorithm?
One area that's showing a lot of promise is deep learning.
Deep learning.
Yeah.
Yeah, I've heard that term a lot lately. It seems like it's everywhere these days.
It is. Deep learning models, especially artificial neural networks, are already incorporating elements from different tribes.
So deep learning is kind of like a melting pot of machine learning ideas.
You could say that these models can be incredibly complex with millions or even billions of parameters, and to train them effectively, you often need to combine techniques from different tribes.
Like using backpropagation from the connectionists, along with Bayesian optimization techniques.
Exactly. It's all about finding the right combination of tools for the job.
So we're starting to see these hybrid learning machines emerge. But what are the biggest obstacles standing in the way of this grand unification of machine learning?
Well, one of the biggest hurdles is simply the complexity of learning itself.
Right. Learning is this incredibly intricate process with so many nuances.
Exactly. Capturing all of that in a single algorithm is a monumental task.
It's like trying to map out all the neural connections in the human brain.
We're still trying to figure out how biological brains learn, let alone how to create artificial systems that can match their versatility.
It's like trying to build a skyscraper without a complete blueprint. We have some of the pieces, but we're still figuring out how they all fit together.
And on top of the theoretical challenges, there are also practical challenges.
Like what?
Well, as these machine learning models become more complex and the data sets get larger, the computational demands just explode.
So we need more powerful computers to keep up.
Exactly. Even with the most powerful supercomputers we have today, training these models can take weeks or even months.
Wow. So we're facing both theoretical and practical challenges in this quest for the master algorithm. But let's zoom out for a second and look at the bigger picture. What are the potential implications of finding this ultimate learning machine? How could it change the world?
The implications are huge. A master algorithm could revolutionize countless fields: medicine, science, engineering, finance, you name it.
It could accelerate scientific discovery, personalize healthcare, optimize transportation systems, create new forms of art.
It could even help us understand the universe in ways we can't even imagine right now.
It's mind-blowing to think about, but with such potential comes great responsibility.
Absolutely. We need to be very careful about how we develop and use this technology.
What are some of the ethical considerations we need to address?
One of the biggest concerns is bias. Machine learning models are trained on data, and if that data reflects existing social biases, the model will learn those biases too.
So it's like teaching a machine to be prejudiced.
In a way, yes. We need to be extremely careful about the data we use to train these models and constantly monitor them for signs of bias.
And what about the impact on jobs? As these machines become more intelligent, they'll inevitably start automating tasks that humans currently do.
That's a very real concern. We need to think carefully about how to prepare for this transition and make sure that everyone benefits from these advances in AI.
It's a huge challenge, but it's one we can't afford to ignore.
Exactly. We need to find a way to harness the power of AI for the good of all humanity.
This has been an incredible conversation so far. We've explored the diverse landscape of machine learning, searched for the elusive master algorithm, and grappled with the profound ethical implications of this technology.
It's a journey that's full of both promise and peril.
But ultimately, I think it's a journey worth taking.
I agree. The possibilities are endless.
Okay, so we've talked a lot about the theory of machine learning.
Yeah.
But now I want to get to the practical stuff.
Okay, sure.
Like, how is all of this actually impacting our lives? Where are we seeing machine learning in action today?
Oh, well, machine learning is everywhere these days. It's not just some futuristic concept. It's already woven into the fabric of our lives.
I think a lot of people hear machine learning and they think of like robots and self-driving cars.
Right.
But it seems like the applications are much broader than that.
Oh, absolutely. It's way more pervasive than most people realize. Like, take healthcare, for example.
Okay. Yeah, healthcare seems like an area where machine learning could really make a difference.
Oh, it already is. Machine learning is transforming the way we diagnose and treat diseases.
Really? How so?
Well, one area where we're seeing huge progress is in medical imaging.
Medical imaging.
Yeah, like X-rays, CT, scans, MRIs, that kind of thing.
Okay.
Machine learning algorithms can now analyze these images with incredible accuracy, sometimes even better than human radiologists.
Wow. So it's like having an AI-powered assistant that can help doctors spot things they might miss.
Exactly. And that can lead to earlier and more accurate diagnoses, which is crucial for effective treatment.
Especially for something like cancer.
Oh, yeah. Early detection is key with cancer.
So machine learning is literally saving lives.
It has the potential to, yeah.
That's incredible. What other areas of healthcare are being impacted?
Well, another big one is drug discovery.
Drug discovery.
Yeah, developing new drugs is a really long and expensive process.
Well, I can imagine.
But machine learning is helping to speed things up. It can help researchers identify promising drug candidates, predict their effectiveness, and even optimize their design.
Wow. So it's like giving researchers a shortcut in the drug development process.
Yeah, pretty much. It's a game changer for the pharmaceutical industry.
And it's not just about developing new drugs, right?
Yeah.
What about personalized medicine?
Oh, yeah. Personalized medicine is another huge area where machine learning is making a big impact.
Like tailoring treatments to each patient's unique needs.
Exactly. It's all about using data to create more targeted and effective treatments.
That's amazing. It's like having a doctor who knows you inside and out.
Yeah, it's pretty cool. So we've seen how machine learning is transforming healthcare.
Right.
But it's also having a huge impact on the way we interact with information.
Oh, yeah. How so?
Think about search engines. They use sophisticated machine learning algorithms to sort through billions of web pages and find the most relevant results for you.
Right. It's like having a personal librarian who knows exactly what you're looking for.
And it's not just search engines. What about those recommendation systems you see on like Netflix or Amazon?
Yeah, those are pretty good at figuring out what I like.
Right. Well, those are powered by machine learning too. They learn from your behavior and preferences and get better over time.
Sometimes it feels like they know me better than I know myself,
Haha. Yeah, it can be a little creepy sometimes.
but also kind of cool.
Definitely. It's a double-edged sword.
On the one hand, you have this incredible personalization and convenience, but on the other hand, there are concerns about privacy and control.
Exactly. Who has access to our data? How is it being used? These are important questions we need to be asking.
So machine learning isn't just a technological revolution, it's a societal one.
I think so. It's changing the way we live, the way we think, even the way we see ourselves.
This has been a truly eye-opening conversation. We've explored the theoretical foundations of machine learning.
Right.
We've met the 5 tribes.
Yeah.
We've searched for the master algorithm.
We've covered a lot of ground.
And we've seen how this technology is already impacting our lives in profound ways.
It's a rapidly evolving field, and it's only going to get more influential in the years to come.
So we need to stay informed and engaged.
And absolutely.
We need to understand the potential benefits and the potential risks of this technology.
And we need to make sure that it's used ethically and responsibly.
Well said. Well, folks, that's it for this episode of The Deep Dive.
Thanks for listening.
A huge thank you to our expert for sharing their insights today. And thank you to all of you for joining us on this deep dive into the world of machine learning.
Hope you learned something.
If you enjoyed the episode, don't forget to like, share, and subscribe to The Deep Dive for more explorations of fascinating topics. Until next time, keep those minds curious.